Hey guys, today we're gonna be doing a weird little challenge. As y'all know, if y'all just look on my channel, I've already posted today's Codeforces every day until GM. Today we're gonna be practicing a little bit different. We're not gonna be solving 1200s. We're not gonna be going for harder problems. We're gonna be solving 800s today. Why 800s? Well, I don't know. In my last few contests, and I've complained about this quite a few times if you've been watching my videos, I've been solving A and B, or like at least A, kind of slow. Like it takes me a while to like see the pattern, and then maybe the implementation is tricky. Usually it isn't, but if it is, then I really struggle with it. Why did everything go to Russian? Okay, weird. Um, but So that's what we're going to work on today. We're going to see how many 800 rated problems I can solve in an hour. We're going to solve them for speed. I have a little timer. The goal is 5 minutes. I think most of these questions take me 10 minutes. If I fuck up, it can take me even more. But the goal is to get this time down to question 8 in 5 minutes. Which is going to be hard because reading will take a lot of the time. This basically means I need to read it maybe like once or twice max, and then be able to implement it in like 2 minutes, and then submission's a thing. But like you can't really do anything about submission, right? So that's the goal. We've been recording for about a minute and a half. Let's just get started, and we'll do as many of these 800s as we can today, until an hour's up, or I get bored, or I don't know. We'll see. Alright, so I'm not looking at the question. I will always just like format the problem first into my Codeforces. And then, alright, I am ready. Alright, 3, 2, 1, let's go. Okay, a path in a greedy grid is called greedy if it starts at the top left cell and moves only to the right or downwards, always moving to its neighbor with the greater value, or either if the values are equal. The value of a path is the sum of the values of the cells it visits, including the start and end. Does there exist an NXM grid of non-negative integers such that no greedy path achieves the maximum value among all down/right paths? Okay, so we take an input, we take an in and m, so t equals int input. Bit unlucky, because usually I can just copy and paste this. We take an in and m equals map int input split. Okay, this is fine. And so what are we given? N and m is the dimensions of the grid, right? And then you can only move right downwards. Does there exist an NM grid? The value of half sum of the cells including. Does there exist in such that no greedy path achieves the maximum value among all the down right paths? Okay, let's take a look at the example. In the first test case, example of a grid with no greedy paths achieves the maximum value of all down right. Okay. Maximum value is A1, 2, is this row column, RC? Right, I'm assuming it's this. 3, 5, 1, 17. Wait, is it this? This looks bigger. 10, yeah, it's this. So this is column row, I think. 10, 14, yeah, it is. This path isn't greedy because A1, 2 is greater. Okay, yeah, I see. Maximum value of a greedy path is. So we need to find the greedy path, and we need to check if it's the max path, I guess. So 800 rated. I mean, is this just simulation? we're just given a grid, right? What is the grid filled with? Number of test cases, number of rows, columns. What? I don't get it. How are we filling this? Moving to its neighbor with the greatest value. This exists a grid of interest such that no greedy path achieves the maximum value. Okay, so is this any grid? Any 3x3 grid? So I'm assuming it's always possible. Because it doesn't actually matter, like we can just ignore everything and do like one and like infinity, and then like infinity, 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 one, yeah, something like this. The centers don't actually matter, so it's always possible. It's like print, yes, but there's like a few impossible cases, I think. If I'm understanding this question correctly, before I submit, I'll reread. 1, 2, so it's like this, right? Or like 2, 1. Because they only have one path. If it only has one path, then it can't be greedy. If n or n or m, print no. Continue. No. Why does this print no? Go. And then, what about 2, 2? 2, 2 doesn't work. It's like, it's, this could be 3. Pick the greedy path. Pick 2, 3. This is 5, 6, 7. What if we do like 2, 2? This equals this. 2, it's impossible. It's always greedy. I mean, unless it's like, uh, like this, and it goes like, oh, you can only go like this way or this way, right? I think this is pretty close. It's taking me 7 minutes so far. I can submit it. Maybe I'm missing something? Wrong answer. Okay. No, fourth token. 1, 2, 3, 4. Wait, why is this the case? 7, 2. Something like this. 1, 2, 1. Like this. Maybe. 3. We would do this. No, this is 1. Make this 2. What happens if there's a tie? Um, I don't understand why this is the case. Wouldn't it always be greedy? What if I had like 3, 3, 1, then I had like a bunch of 2s down here or something? Like 3, 1, 3, and then 2. Maybe 2. Well, you would greedily choose this 2, right? So if it's under the 3, it has to be a 1. And then if we get to 1, it's the 3. Greedy path. 3, 4. Huh, I don't know. Okay, if I took away this column here, what would I get? If by taking the greedy path, I go 8, 9, 13. By going this path would be 9. Okay, so it is possible for 2. I think it's just 1. If there's only one path. What about 2, 2? Something like this. I think. Okay, we got it. That took us 13 minutes. Let's look at the editorial, because I'm not too sure what... I don't even know if I fully understand what this question's asking. If n equals 1 or m equals 1, there's only one downright path that's trivial, greedy, and maximal. Yeah. Equals 2. Any path must choose between the two, clearly. Okay, yeah, this is correct. All other such cases, a grid does exist. Yeah, okay. I don't really care for this bonus. Okay, that's what I thought. It just took me 13 minutes to get there, computationally in my head, which is not good. So that's slow. It's much slower than what I would like to be at. Okay. Alright. Ready and go. We are given a string s of length n consisting of lowercase letters of the Latin alphabet. Determine whether there exists three non-empty strings a, b, c such that a plus b plus c equals s, meaning the concatenation equals s. The string b is a substring of the string a plus c, which is the concatenation. Okay, I know what a concatenation is. So we're taking this, and then we take in equals input, and then we take in an s equals input. So we need to change this to in, and then that's our input done. So what do we need to do? For each output, yes, if there exists three non-empty strings that satisfy the conditions, otherwise print no. Okay, so our conditions are ABC equals S, and B is a substring of A plus C. So basically, B will be a substring of A plus C if B is equal to A or C. Okay. Check 1, check 2. I feel like this is pretty simple. I can just do this, and then at the end, if check 1 and check 2, print yes, else print no. And then for check 1, if A plus B plus C equals S, check 1 equals true. Oh, I see. We're not given ABC. Okay, so given a string, if there's a duplicate, then it's yes. Or are ABC all different strings? A plus B plus C equals S. This is S. Hey, let me see for case 2. In the first test case, there exists unique. A sixth test case. 1, 2, 3, 4, 5, 6. PP. Okay. The seventh test case. It's also a yes. I want one that does no, though. Like the eighth test case. Maybe C, D, A. A. So A, B, C. Okay, so as long as okay, check one is useless. Check one's yeah, we don't have to check this. We only have to check for check 2. And to do that, we kind of just check if either the first or last is in the middle of the string, I think. If A, if S, O, in S, 1, -1, wait, this is exactly what I want. 4 should be no, right? Yeah, okay. Or S, -1. Okay, it's over. Yes, no, no. I feel like case 5. Because I can split it here, right? A, B, C. Or, so there's one more check. If the ends are in the center, or the center has a duplicate, or set len set this not equal len this. There we go. There we go. We got it. About 7 minutes. That's much better. Let's take a look at the editorial. Above the clouds. Notice that if there exist 3 non-empty strings ABC, then there exist 3 non-empty strings that satisfy. The length of string B is equal to 1, yes. To achieve this, one can choose any character from string B, append all characters before it to string A, and prepend. And then you just check if B exists in either, right? But then it's like, which B do you choose? Okay, bro, that's so much code. I ain't looking at that. But yeah, I think the idea was like, if it's so we take a look at everything in the center. If there's a duplicate, then it's possible. Or if this is in here or this is in here, it's also possible. So do we just check for duplicates? Like, can I simplify this question to be No, it's not. Well, you can just check for duplicates in this and this, right? It's like two if statements. Yeah, it's basically the same thing. I do 3 checks. You can simplify this into 2 checks. I'm pretty sure. Um, it's trivial. Okay, 2 questions down. Let's do another. Um, bang, bang. Close this. Reset this, and then copy. Boom, boom, boom. Rating 800. Okay. We call a bit string perfect if it has the same number of. Oh shoot! I forgot to start the time. Of ones. Okay. Sequence. Construct a perfect bit string of length n where the number of one characters it contains is exactly k. It can be proven always possible. Okay. T and k. So copy this. All right. Um. Same number of 101s and 010s. Construct a number of one characters contains exactly k. So for we are allowed 101, 010. Okay, so basically the idea is 1010. This or like 0101. These combos are like exactly the same, right? 3 101 53. What? How's in the second test case? How? Where's the? Am I tripping? This is 101 010. Um. Subsequences. Subsequence. Not substring. So it's 101, 101, and then 010. Okay, this makes it a little harder. So what's the new pattern? We can basically shove zeros and ones in any of this, right? As long as they're like, we group them together, I think. So, like, we should never have a triple one. Or, okay, what is this case? We should have for number of ones. Right. Construct a perfect string length in contains exactly k. It's k2. Length 6 and 2. Okay, yeah. 5, 5. Okay, so first, if n equals k, print 1 times k. Does this work? There we go. And that should cover these 2 cases. And then else always possible. Do we not just put all the ones in front? Can I do like, let's pick a case. 5, 3. Need 3 ones. So can I do 1, 1, 0, 1, 0? We have 1, 2. No, I can't. 1. So instead of doing that, can I do 1, 0 here? There's 1, 2, 1, 2. I can't, so I just shoved the ones in the middle. I think so. And then here I put k minus 1. I think. This case is failing. It's isolated 6-2. Expected. Oh, where do I put the zeros though? One, two, three. If I do 1, 0, 1, 1, 0, and then I add a 0 here, then it doesn't matter. So I can just do plus, oh, 0 times n minus 2 minus k minus 1. My math off. Something ain't right. Let's just do this. For now, this works. Because it's n minus k. Why does this work? 4, 2. Right. Our first one is here. Our second one is here. We have 0. And then this is n is 4 minus 2 minus these 2. Yes, so it's just n minus k minus 1. And then I get rid of this. Okay. Wrong answer. Wait, is it? Yeah, it is. What does this mean? Test case 1. Length is 1. Come on, Codeforces. I'm waiting. Why is this taking so long? Hello? It's on test 2. Okay, buddy. Just have a 0, right? That's right. We got 1-0. Okay, is my formula wrong or is it edge case behavior? Test case 3. 1, 2, 3, 2. Oh. K equals 1. Or K equals 0. Okay, if K equals 0, print 0 times n. Continue. Why? Oh, it needs to be a string. Okay. There we go. Okay, that took way too long. 12 minutes. Alright, 3 questions down. I'll do a quick restroom break and then I'll be back. Okay, I'm back. Let's just jump right into the next problem, I guess. Boom, 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 boom. Oh, I got rid of my timer. Alright, let's go. Shrink an operation on an array of A of size m is defined as follows. Define the score of a permutation P as the maximum number of times you can perform the shrink operation on P. Yusuf has given you a single integer n. Construct a permutation P of length n with the maximum possible score. If there are multiple answers, you can output any of them. Okay, so we're given T and then an n. So like this. Okay. Now what do? Choose an index such that is size m. The previous index is greater than, or the current index is greater than the previous, and the current index is greater than the next. So it's a zigzag almost. Maximum number of times you can perform the shrink operation on P. Okay, let's take a look at this. Choose index 2, remove 1. Okay. Okay, I get it. So if it's a mountain, we remove it and we want to maximize mountains. Alright, so I feel like it's some uh like 1, 2, 3, 4, like type of thing. You know what I mean? 1, 2, 3. 1, 2, 3, 4, 5. Okay, let's try 6. 1, 2, 1, 2, 3, 4, 5, 6. So first, let's start in the middle. Pop, pop. Wait. Pop and pop, pop. And then we're down to 1, 2. So it's always going to be n minus 2 operations, which means we can just actually 4. Yeah, we do 4, right? 1, 2, 3, 4. Yeah, I think that's correct. So we just need to implement this, which is for I in range in if I mod 2 is equal to 0, we're on the left, otherwise we're on the right. I need a 2 print. To print counter think we do this either way. Wait, let me think. It starts at 0, right? 0. Okay, first let's start at 1 and then go to n plus 1. We're at 1. So we're at 1, so to print should have is 1. We're at 2, and then we check here. Counter is set to n, which is 6 minus 1 is 5. So then we go 0, 1, 2, 4, 5. 1, 2, 3, 4, 5. And then we have 1. Let's just run this and see what I get. Star to print. This isn't right. Is it because I don't get it. It's because I use double equals here. This isn't right. Wait, is it? No, it's not right. 1, 2. Why is there 0 here? Isn't it just, okay, odds increasing and decreasing? Yeah, I don't know, I'm trying too hard. It's 7. Yeah, I think this is right. Come on. I want Codeforces. There we go. 11 minutes, not bad. I fucked up the implementation, but I got it. We can probably do one more problem. Reset. 800 actually. Okay, let's go. A proud owner of n sticks, each stick has an inch length from 1 to n. Length of the sticks are distinct. You want to arrange the sticks in a row. There is a string s of length n-1, describes the requirements of the arrangement, specifically for each I from 1 to n-1. If si equals this, the length of the stick must be smaller than all sticks before. If si equals this, larger than all sticks before. Take in t in, and then a what? S. Okay. Oh, less than, greater than. That's what these are. Okay. For each output, the length of the sticks in order if there are multiple solutions per any. Okay. So 2 less than. Huh? The length of the stick at I plus 1 is smaller than. Okay. And then the opposite. Yes, this makes sense. Second case. Smaller, smaller, greater, smaller. Yes, this is smaller than this. This is smaller than this. This is greater than everything in this, and this is smaller than everything. Okay, so we kind of just mark the graders as the indices, right? We do graders first, and then we do smallers. So we need to create an array to print of 0 times n, and then we pass through for char in, for char in s if char equals greater to print. Okay. Okay, for I in range n, if si is greater to print I equal to cur minus equals 1. Wait, if there's multiple, it's like 5, 6, 7. So we should actually do it backwards. We should start from n, go to 0, -1, and then go forward. Print star, print something like this. Okay, next out of range. This is for this one. Si, we're at n -1. It's gonna be n -1, right? So, is it? Okay, all we know is this is 0, 1, 2. This is 0, 1, 2, 3. This is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5. So it's like, how are we not getting any input? Like, we're here now? Okay. What's going on? We get 2. We get 2. Okay, so we have 6. Or, okay. Line 2, 1. So what we should do is put a blank here. But if it was this way, we want to. Right, and then just do anything. Zero, 2. 4, 3. Something ain't right. So the first index that okay, when I'm given like what I should be doing is this, and then in this index I should place the biggest number, and then for the rest 4, 3, 2, 1. No, and then if I have like, let's just take this one for example. This, 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 this. I should have this, right? And then our thing is 7, so it should be 7, 6, 5, 4, 3, 2, 1. Yeah, this behavior is correct. So what I should do let's just remove all this. Start from the back. In to 0, -1. So let's isolate this case here. 7, 6, 5, 4, 3, 2, 7, 6, 1. Okay. So 8, 1. Then bring this down 1, I think. Now to print. Okay, if si is equal to this thing, to print dot append cur minus equals 1. It's not append, it's to print I equals cur. No? Why have I been doing this double equals BS? Okay, yeah, this is correct. Now, for I in range in, if to print I equals 0, to print I equals cur minus equals 1. There we go. Why was that so difficult? Longest implementation yet. Jesus, it's quite slow today. What kind of tests did they got for this thing? Military grade? There we go. Alright, in an hour, I was able to do 5 800 rated, and my time spans anywhere from 7 minutes to 15 minutes doing these problems, which is slower than I want to be at. I want to be at 5 to 10 minutes. So I have some improving to do. Maybe I'll do these like speed practices a few times a week, once or twice a week, 3 or 4 times a week. I don't know. But yeah, I guess this helps with implementation too. Or like just seeing different types of problems is always good, especially when you can do them fast. I think I've done a lot of 1000 to 1200 rated problems lately, so like I definitely still am working on solving harder problems, but doing easy problems fast is just as important, right? So, alright, if y'all enjoyed this video, be sure to like and subscribe. I'll see y'all guys soon. Bye.